Hi and welcome to this tutorial session. In today's tutorial, we want to find all the solution of the radical equation 2 root x to the power 3 is equal to 8. Alright, so please watch every step of the way because we will be bringing in good insights. Let's start. 2 root x all raised to the power 3 is equal to 8. So we want to find all the values of x that will render this equation true. Okay, so if we look at it, this is raised to the power 3. 8 is also 2 raised to the power 3. So let's write that out. So we have 2 root x raised to the power 3 is equal to 2 raised to the power 3. Now we should avoid the temptation to say that since the powers are equal, we should just go ahead and equate the bases and solve. If you do that, you're going to get just one of the solutions. Okay, actually we're supposed to have 3 solutions because this is a cubic expression. To get all the 3 solutions, we take this expression from the right hand side to the left hand side in order to have a 0 on the right hand side. Let's go ahead and do that. So we have 2 root x cube minus 2 cube is equal to 0. Now the left hand side is a difference of 2 cubes. Okay, applying the difference of 2 cubes identity here, we're going to obtain 2 root x minus 2 into, we square this, we obtain 4. Let's first of all write it out. Will be 2 root x squared, all right, plus their product, 2 multiplied to that is 4 root x, and then 2 squared plus 2 squared, which is 4, is equal to 0. All right, now we get this expression multiplied to this expression giving us 0. That is only possible if either this first expression, 2 root x minus 2 is 0. All right, let's solve for x in this first case. 2 root x minus 2 equals to 0. 2 is common. We'll factorize out 2. 2 into root x minus 1 equals 0. This product giving us 0. 2 is already a constant. It has its value 2. You can never change from 2 to 0. So this 0 must have been brought about by this other expression. So this means root x minus 1 is 0. Right? If we take the negative 1 from the left hand side to the right hand side, we obtain root x equal 1. All right, if we square both sides, we're going to obtain x equals 1 squared, which is 1. This gives us our first solution. So the value x equals 1 is our first solution. Now let's get the other solutions, the other two solutions. The other two solutions are going to come from this. Okay, we said either this is 0 or this other expression is 0. So we have already used the either. Let's continue with the or 2 root x squared, I'm repeating this expression, plus 4 root x plus 4 must give us 0. Now this square here will affect this 2 and will also affect this root x. So 2 squared is 4. Root x squared, the square will simply cancel the root and we got x. So we have the 4x plus 4 root x plus 4 equals 0. Now this is actually a quadratic. All right, if we just look at the step preceding, all right, if we forget about this one, for example, let's instead modify this one so that we can see the quadratic nature. Let us apply the square on 2 and let this one remain. So we're going to have 2 squared is 4, like we got here. 2 squared is 4. Then here we will not carry out that operation. We'll just say 4 into root x squared. Okay, and then we'll continue. We have 4 root x plus 4 equals 0. Okay, so here we see clearly the quadratic nature. So it's a quadratic in terms of root x. To make it a lot clearer, let us make the substitution y equals root x. So wherever we see root x, we're going to put y. That our expression becomes 4y squared plus 4y plus 4 equal 0. So this is the quadratic that is hiding there. We have not brought it out here in a much more visible manner. Okay, we see 4 is common all through. So if we divide all through by 4, divide here by 4, divide here by 4, divide here by 4, divide here by 4. Remember, it's an equality. Whatever is done to one side, we must also do to the other side. All of this simplifies to y squared plus y plus 1 equal 0. All right, this is a simplified quadratic equation. How do we solve this? Let us use the quadratic formula. Our a is 1, our b is 1, our c is 1. So our quadratic formula in terms of the variable y equals minus b plus minus the root of b squared minus 4ac, all of that divided by 2a. Let's put in our ABC carefully. Right, so we obtain y is equal to our b is 1. All of them are just 1, so we have negative 1 plus minus the root of 1 squared minus 4 into 1 into 1 all over 2 into 1. Okay, so we continue this way. So uh, we have y is equal to negative 1 plus minus the root of 1 square is 1. 4 multiplied to 1 is 4. All over 2 multiplied to 1 is 2. This gives us negative 1 plus minus the root of negative 3 all over 2. So we see clearly that we are going to obtain complex roots because the root of negative numbers, we don't have the answer in the real number field. So this cannot give us a real number. Okay, so but we know that we can evaluate root negative 3 by first of all writing it as root negative 1 times 3. This is root of negative 1 multiplied to root of 3. And the root of negative 1 is the imaginary number I. So all of that expression gives us I root 3. So root negative 3 is I root 3. So we'll put it there. So you give us y is equal to negative 1 plus minus I root 3 all over 2. All right, so we have two solutions here in terms of y. Remember, we're asked to solve for x and not y. There's no y in our original question. So we're not stopping there. We have to go back to the relation. All right, the relation between x and y is that y equals root x. So we'll use that relation to be able to get the corresponding values of x for this expression. Y is root x. All right, so in place of y here, we're going to put root x. This therefore means root x is equal to minus 1 plus minus I root 3 all over 2. To get x, all we need to do is to remove this square root. All right, and the only way to do that is by squaring both sides. So if we square both sides, this is what we get. It's equal to minus 1 plus minus I root 3 all over 2, all of this squared. All right, so this therefore means, remember the square root will cancel the square. It therefore means x equals minus 1 plus minus I root 3 all over 2, all of this squared. Okay, now we don't make the error to come and say this square cancel this square root. No, It doesn't work like that. This is an expression involving 1, 2, 3 terms. So the square root has to affect all of them at the same time. So we are therefore saying that our three solutions are, the first one was x equals 1. All right. Next one is x equals -1 plus I root 3 all over 2 squared. And the last solution is x equals -1 minus I root 3 all over 2 squared. Okay. Maybe this one is not visible very well. Our last solution is x equals -1 minus I root 3 all over 2 all of this squared. 1, 2, 3 solutions.